You're listening to Cultivation Elevated, hosted by Michael Williamson and Anders Peterson, where we discuss vertical farming and the future of cannabis and food production.
Hey, what's going on, everyone? From Pip Horticulture, I'm Michael Williamson, along with Anders Peterson, and you are listening to Cultivation Elevated, the podcast where we dive into all things cannabis, food crops, controlled environment agriculture, and vertical farming. Today, we're excited to share some insights on drying and curing strategies. This is part 2 to a series that we're doing. On our previous podcast, we touched base on some of the pre-harvest and harvest strategies.
We wrapped up last episode essentially, moving things to the dry room. And I think that's kind of where I wanted to pick up was, I would say one of the first questions I get a lot, especially in the design of dry rooms and when I was doing HVAC designs for dry rooms, doing moisture calculations was, a couple of basic questions I'd always ask is, are you whole plant hang drying or hook and hang? And hook and hang, for those that aren't familiar, it's what I like to call when you break down a plant using the stalk as kind of its own hanger. So you cut the plant up so that you have a branch, but you make a natural hanger and you can hang it on a line, on a hanger, whatever plant support system you're using in the dry room.
It's a natural plant hook, essentially, instead of using like an S hook or something else that you'd have to touch and clean and sanitize.
Mm-hmm. And, I think there's arguments both ways, doing whole plant versus hook and hang. I will say for the first 5 or so years of growing, I did hook and hang. I can't tell you exactly why. It was kind of like the mentor who taught me growing. Were you restricted on
space?
We were restricted on space, but it was also, I think, it was black market back then, and kind of the OG hippie guy who brought me into his garden to learn when I was young. That's just how he always did it. And so that's how we always did it. And it wasn't until years later that we started doing whole plant hang. But definitely, I think it was space restrictions. And there's an argument about, you're going to cut that plant up later anyways. Why not do it right away? My argument
is removing some level of moisture out of the equation too, because if you're typically getting that main stalk out of the equation and using just the side branching to create those hooks, but usually space restriction is why I see people doing that the most. And I've done the same thing. I've kind of tried it all ways. I would say today I'm mostly a whole plant hang, but we're also typically growing on a multi-tier where, our typical plant size is in that maybe 3.5 to 4 feet. And previously when we were single tier, in under HPS lighting, a decade ago, we were growing a 6 or 7 foot plus tall plant, which was another reason why we broke it up, because it just kind of made sense for us spatially. It's a lot of whole plant to hang.
And I think that what you just described is pretty common in the industry today. I think hook and hang is definitely still around. I still see it in facilities. But definitely for those that are growing taller plants, I think just with the adoption of LED lighting and multi-tier cultivation, you're seeing smaller plants, higher planting density than you did in the single tier HPS days. And so, yeah, I think whole plant is a lot more common today. That's definitely what I do, growing smaller plants.
Well, it's faster. I think that's something that's worth mentioning.
Well,
people are getting smarter about, obviously grams per square foot matters, but you hear more and more people talking about how many harvests am I getting per year? And if you're trying to load a drying room in the morning or for sure the same day, it's going to be faster in a whole plant scenario than having to break that plant down, where afterwards you have a little bit more maybe leeway or time to break down a plant. So that is probably another reason why I see people that have the space to do so are going to a whole plant hang.
And that's a great point. And that's one of 2 reasons that I think most facilities do whole plant today. One being, like you heard on our last episode around pre-harvest and harvesting, there's a lot to do in a short period of time to get a harvest done. There's just a lot of tasks. And this removes one of those from that day, having to cut the plant down and hang it. It's less touches, it's less tasks for that labor intensive harvest day. That I think is a huge factor. The other is compliance. It's easier to track your plants into the dry room when they're whole than when you start breaking them down. It becomes very difficult compliant wise on metric or depending on the state you're in. The hook and hang gets a little bit trickier because in most states, right, once you start bucking and the plants are dried, that's when it starts becoming a harvest batch, not a per plant, not tracking per plant, but tracking per batch.
Hmm.
And so it's just a little bit easier to deal with compliance wise. But I would say still most people today are doing whole plant hang. And I think that leads into kind of the next topic, which is always an area that I'm curious to ask people how they plan to do it. But I don't know the right term, but I would say, how do you plan on supporting your plants in the dry room is the question. Essentially, how do you plan on hanging it? Right. And there are so many different methods that all work to hanging plants in a dry room. There are some that are better than others, some more efficient than others, but a lot of them work, right? And it's always interesting to see what some growers prefer. The reason there's so much variability in how you can hang plants in a dry room is exactly why there's so much trouble in sizing a dry room. So it's a question I know you get a lot. It's a question I get a lot. Hey, you have a good rule of thumb or a good metric to size my veg canopy based on my flowering canopy? Do you have a similar metric or ratio to size my dry room? And I've heard a ton of different ones. People have given me, I'm not even going to repeat them because after time, you realize none of them have held true across all the scenarios that we see. And so, unfortunately, there's not a great ratio of like cubic or square footage. It totally depends on how you planned on supporting those plants in a dry room.
Well, and what are your end products, right? We always have to
Yeah.
start there too. It's like, oh, do you know for a fact that 20% of your crop is going to go to fresh frozen or 30 or 40 or 50? Because that changes everything. If you know you're going to be a flower centric brand and you're going to have to dry 100% of that product, then, that helps a little bit. Um, I know maybe whoever's listening is like, oh, well, these guys are with PIP, so they're just going to promote this PIP product. But one of the things I really love about our traditional, we call them finger hooks, um, is I know for a fact I can put two plants per side of one of those hooks, but I'll spec most at one.
Hmm.
One is ideal. Can I make two work? Absolutely. But I know that if I calculate my flower batches off of one plant per hook, then no matter what changes come in the future, I literally have double the physical capacity if I need to.
Hmm.
Um, so, you know, there's pros and cons, and I think we kind of let's try and talk about a few of the most common ways to do things. And I know we're gonna have to
Sure.
use this as a like an oral narration, which will be a little bit difficult. But for the PIP offerings, we have a couple different options. We have our traditional mobile systems. That is a pallet rack essentially that goes back and forth, or in our case, it's a rivet rack in most situations. So we can do our bulk rack as well for larger dry rooms and people that want to utilize the Elevate platform system, which is kind of nice. Gets you off the ladder essentially. The benefits of our racking system is you're maximizing all of your cubic footprint. You're catching all that high ceiling that if you have it at your facility. The other option that we have, and on that
But
system
not
is
just
these,
cubic, yeah, but cubic and square footage, right? Just
yeah,
like
that's
our
fair.
cultivation racks, they're on a track. They go left and right. You have one working aisle or a mobile aisle, and you don't have static racking, so you're not wasting square footage. And with the vertical height of the racks, which is customizable, you get that cubic footage. So it's a good solution. And then, yeah, sorry to interrupt, but
No,
the
no,
other,
you're spot on. The finger hook part is nice because it essentially you just take the whole plant and you just hang it right up on there, almost like if you were hanging up your jacket on a coat hook, so to speak. So it's kind of toolless. There's no secondary parts to clean. All of those can modulate in terms of what distance they are from each other. So if you had like a bushier crop versus a lankier crop, you can micro adjust those appropriately so you can space them out. They're not like welded and fixed in place, so to speak. Our other offering also utilizes the finger hooks, but it's a mobile cart system. Usually about two tiers or two elevations on the cart. Unless you're going into one of the elevated carts, you might be able to get three. The big thing with the carts are they take up a lot of space when not in use.
well,
And
this is a
they're
good topic. And I think regardless of whether it's the PIP mobile bulk rack drying or one of the other methods like vertical trellis net or, you know,
Cable wire.
steel cable wire with eyelets or what have you. You basically have solutions that are within the room, stationary within the room, and optimize that vertical height and cubic footage of your room. Or you have a more cart method that you're loading up a cart in the flower room, wheeling it into a drying room, and the plants aren't touched again, right? There's pros and cons of both. And so, but yeah, go ahead. I think not just
Well, the
comparing
cart's
against pips,
romantic.
but
The cart's
yeah.
romantic on paper, right? Because what you just said, hey, I'm going to hang this plant on the cart in the flower room. I'm then going to wheel this thing out. I'm going to put it in the drying room. I don't ever touch the plant again. Oh, it's done. It's done being drying. I wheel it out of the drying room and maybe I bring it into the bucking room or like some kind of flex space or the cure room or whatever it might be. And so on paper, you're like, wow, we don't have to touch it 3 times. That sounds really good. The downside of it is, the average door height's like 6 feet, 6 or 7 inches. And so you have to have a cart, unless you plan for really tall doors on the path of the plant from drying, I'm sorry, from flower to drying and then to the next process. Let's call it a bucking room. You're not maximizing your total cubic footprint. You're also going to spend a lot more on doors. And people don't think this in the production process, but when you look at your door schedule and how much it costs, you start getting the custom doors, it's a huge number. Um, and so the cart seems like a great idea. All those carts have to be cleaned. They have to be stored somewhere as well. So, like when you go to clean your drying room, what ends up happening, people that have the cart system that use it for full-time drying, from a storage standpoint and sanitation standpoint, it becomes kind of a big burden. And all of a sudden, you've got carts lined in every possible nook of a hallway and stuff like that. And it does create some challenges. And like I said before, when you're tight on space, you're not maximizing your cubic footprint with most carts.
Okay, let me ask you this. If so, the two things that we're talking or debating right now is the cart method, which is loading it up, touching it once in the flower room, and wheeling it into a dry room. The option two is whether it's the per pip vertical mobile system or the trellis, one of those other kind of hanging systems, requires multiple touches, right? You're bringing the plants from the flower room to the dry room and then hanging them up. If you were designing your facility brand new and you had the pick, which one would you do?
I would go with like 8 to a dozen mobile carts for transportation purposes only. And I would go with a multi-tiered racking system.
Interesting. I'll
Hmm.
admit, I actually think I might go the other way.
Yeah. But
I,
I'm excited that we're going to disagree. This is what I've been waiting for. Sell me. Sell me this pen, Anders.
no, I think I would plan into my facility floor plan the square footage to go with carts. And I would maybe go with the non-standard doors a little bit taller than normal, but maybe not. Just get a cart that wheels through a standard door, but make sure that I design the dry room to have the square footage to fit the amount of carts I need for a harvest batch. I like the simplicity of not having to touch it once again once I get into the dry room. I just the mobility of it, moving it from phase to phase in the process on that, distinct, it becomes more widgetized, like in terms of visit. It's a widget. It's on the cart. I fit this many plants on it. I know what barcodes are on there. It's mobile, fewer touches. I like that aspect of it. Yes, there is a sanitation concern, but I would argue that most people are probably cleaning their carts more because they're bringing them in and out of rooms than actually cleaning their dry racks that are stationary in a room.
Can you tell me the most common area of a cart that people forget to sanitize? If you had to guess.
I would say the wheels.
Bingo.
Yeah, because I already know that shoes are by far the highest contamination rate in your phone on your
Yep.
body. It's your phone
Yes.
and your bottom of your shoes is what's most commonly going to be a vector for disease. So I would guess it's a wheel. But yeah, I would say that would be my. Plus, I'm a short guy, and so it's easier for me to deal with.
Ah, I see. I see. Okay. All right. So let's debate this a bit. I like this. So you if you are going to be on a cart, when would you do your weights and measurements?
Do you mean for compliance?
Hmm.
I would have a floor scale that I have a tare weight of the cart, and I would wheel it onto a floor scale. minus the tare weight of the cart, count the number of plants and divide it. Most states are fine with that. They don't require you a single plant weight. They're okay if you weigh six at a time and divide by six, right? Or whatever.
That's an unofficial recommendation that we are.
Some states
You need
allow
like
that, some
you need
don't.
a little like disclaimer at
Yeah,
the bottom there. We'll inject that later.
some states allow that, some don't.
Yeah, so obviously anything that we're talking about today, you obviously need to check with your local regulations and make sure that it's in compliance with whatever path. But, there's a lot of different ways to do things and there's a lot of allowed different ways to do things. But that's going to be on you as a listener to make sure that you do that diligence on your, in your home state or country. Um, okay. So now if someone can't afford or doesn't have the room for a floor scale because they are kind of big and they're only used ever so often. So to have up something, you have to plan appropriately for that. It can totally be planned for. But if let's say you can't go with the floor scale and you actually have to hang each plant, you would have to do that in the flowering room, which isn't a big deal, but it may take up more time while you're harvesting. So I used to do that at one of our locations, and then our teams kind of has that lean mentality and they're kind of trained to be measuring seconds and time and how quickly can we do something without jeopardizing quality. And they end up pivoting to doing all of the weights and measurements in the drying room. But in that case, if you're going to go with carts, you'd want to do that in your flowering room because you're going to do that at harvest and then put it on the cart. You wouldn't want to wheel that into the drying room and then take it off, measure it, and then put it back on. It kind of defeats the whole purpose of a cart.
Totally.
My other comment about a cart is I have two of them. One, it's going to take up significantly more space than my drying rooms if I was on the opposing side with the
It's true.
vertical racks, right? So it's
That's
going to
true.
take up more real estate. It's not necessarily revenue generating real estate. So I'm always looking to minimize my non-revenue generating real estate in rooms as much as possible, which isn't always achievable, but it's a mindset that I like to try and train into myself and to the people around me working with me. Um, One of the issues that I've had with the carts in the past, and so you'll get a layout from a company like Pip or someone else, and you'll see that all the carts are all lined up perfectly. The reality that you will ever be able to achieve that are slim. And
That's a good
so
point.
it gets a little tricky too. And like, let's say you go, oh, wow, the back of the room is drying faster than the front of the room. Well, in order to go get to that crop, maybe I need to harvest that one a day or two sooner in the drying process. But now to go do that, now I'm kind of playing that Rubik's Cube type game where I'm kind of, okay, I got to move all these out of the room maybe so I can get to the ones in the back, or you got to play this shuffle game. And
Well,
so
see, maybe that's why I like it so much because I love Rubik's
I
cubes.
know
So,
you're a puzzler. Um, so no, I don't think there's a right answer here. I think it's really based on preference, real estate, and
yeah.
budget. Um, when I've done this in the past and gotten comp analysis, the carts are typically cheaper than the racks. Um, but these are all, you have to look at total costs. You have to look at operational costs, and you have to look at risk and reward too. So
Yeah, I
let's
mean,
talk.
for me, if I can remove a labor step of someone having to raise something up or whatever, I mean, I just am always looking for ways to shave labor. And if I can design that into the process up front, great, because that's my highest cogs. Like when it comes to production costs, it's like, how else can I design in lower labor into my process?
Hmm.
But, given that, let's say I have a building that we're designing a facility for, and there's only so much space, if the square footage doesn't allow for carts, like you mentioned, it's not a revenue generating space technically compared to like say a flower room, then no, I won't go that route, right? But if I had the space, I was able to design the building, I would probably go down that route of carts. Um,
It's an economical solution if you have the space. And what's nice about carts is you typically keep people's feet on the ground.
mhm.
So, I can see pros and cons in each, and depending on the application, I'm comfortable when I'm in a design setting or scope of work. I'm comfortable scoping either one based off of the parameters, budget, and team preference.
Yeah. I would say one of the challenges with carts too is, you have all your wet weight now lower in the room. And so your climate control and moisture removal, you gotta plan for all of that wet weight 6 feet off the ground at most.
You're more likely to bang up your door frames and do damage to your facility with carts, but that's also going to happen with the transportation carts as well. You're more unfortunately likely to someone's going to inevitably sprain a finger or even break a finger. I've seen some of that on carts. Just it's just reality.
I'll tell
I
you, the
guess you
trellis
could
net was one of the most frustrating things for me. And I did it for a while, where you hang trellis
explain
net,
that. Explain that. You hang it vertically, right? So you
hang it
trellis net,
vertically.
we think about it as a horizontal hang as you were supporting plants, but in the drying space, we're actually hanging it typically from unistrut and some hooks on the ceiling. And you're basically, if you've ever gone to like go buy a rug, and you flip the rug thing and they're all vertically hanging, it's kind of similar to that. And some of them are more um, slick and like effective than others. Some of them are stationary, and then some of them actually glide and slide on those unistrut so that you can basically push them all against the wall on the back wall and clean your floors really easy. But there's
Yeah,
a lot of different ways to do it. It's very economical for in most
very
approaches.
economical, and it's nice because you can, like you mentioned, I've seen people create frames where the top of these, let's say PVC or even like metal tubed frames,
Strut,
like they use
yeah.
like conduit. They are in like yeah, some sort of like unistrut track on the ceiling, and then they take disposable trellis and they stretch it across that frame almost every harvest or every couple harvests and just zip tie it to that frame. And the worst part is, the first time I did it, we just hung trellis up from the front, and then we like stapled it to 2x4s on the bottom so that we could create some sort of
Get a
weight. I
little
mean,
weight.
a little
Yeah.
bit of weight, or we weaved like a piece of conduit through the bottom of it just to give it some weight to keep it all stretched out from flopping over. But it just became, I don't know, a little bit unruly at times. Some of that vertical harvest net.
If it breaks and it falls, that's a whole issue. Anders mentioned wood earlier, just a minute ago, and I
Well, that
just
was
want to high.
definitely not a licensed facility back then.
Yeah,
That was a long time ago.
that was most likely a long time ago, and I'll say on behalf of PIP, we never ever recommend having wood or cardboard in really any controlled environment space, but especially in drying. We think of wood and cardboard specifically as like food for mold. If
It
you were to look
is.
at like wood under like a high powered microscope, you would just see that there's so many crevices, and it's almost impossible to truly sanitize something like that. So just a slight disclaimer there. Um, Now let's talk about the cable wire a little bit. So people will use like airplane cable hangers, and they'll make them really tight, like high tension essentially, and they'll string them across a room, and then they'll just hang plants over there, almost like you were hanging plant clothes on a clothesline to some degree.
Yeah,
Um,
that's how I started doing it at first. I'll never do it again, though.
why?
We've both heard stories.
I'll share mine after you share yours.
Yeah, I mean, I think it's pretty self-explanatory. We're probably on the same story, but we've both seen those snap and hit people in the face. And it's a safety hazard because you tighten those things, you put a bunch of weight on it. No one's done with a load math to see how much weight you can put on that cable and what those eyelets are anchored to in terms of your wall or whatnot. But I've seen them snap and they're really tight and they hit people. And I just don't think it's worth it. It's not super
The
efficient. Once you lock in those lines, it's like they're set. It's hard to adjust and fix after the fact. Yeah, just not a huge fan of it.
No, I totally agree. We have heard some stories from personal customers and clients that are terrifying. It's one thing to come into a drying room. So if you are going to go down the cable route, it's doable, but you need to ensure that you are anchoring these appropriately and it's something that's structurally sound. Because as soon as they get loaded with wet weight, if they are not, they will break. And if they break, your crop is on the ground. And most likely when they break, no one's in the room. But God forbid someone is in the room. We've seen bolts hit people in the head and have to go get stitches, and have not only lost the crop, then had blood. A lot, when you get hit in the head, there's a good amount of blood. So then had blood all over a brand new drying room, all over a crop, all over down the hallway, and then have to stop during a harvest and take a team member to go get stitches. So you want to talk about a bad harvest day? That's about as rough as it gets. And so one of the things I also, operationally speaking, I don't enjoy about those is when you need to inspect your crops and you have different batches, you have to like crawl or duck underneath those. And it's not just the hanger because you have the hanger, but then you also have a 4, 5, 6 foot tall plant hanging from it. And so it's very difficult to like measure, monitor, and observe your crop during the drying process without crawling around or squatting and doing some of that stuff. And so, and then, like I was mentioning earlier with the carts, let's say the back of the room dries faster than the front, and you got to pull that down a day or two early than you were planning on. Now you've got a whole bunch of crop in the way. So, again, it's how many times do you really want to touch this plant? And the answer is as minimal as possible.
Mhm.
The
Okay,
last one
so
oh, go
oh
ahead.
yeah. No, I was gonna say next topic was climate and
Well,
I
before
wanted
we
to
go
get into
there,
that.
I do want to give a shout out to kind of one of our strategic partners, which is Dry Flower.
Hmm.
Dry Flower came out with a really slick concept that allows you to move a lot of plants at one time and not really touch them as much. And so we've created a hybrid solution that incorporates the dry flower into our mobile racking system. And, moving forward on any new build projects, that's most likely what I'm specing.
Hmm. Yeah, shout out to Jay from Dry Flower. If you guys have never heard of Jay or seen this company, look him up because not only is Jay an awesome human being, but he came up with a really cool solution. He's very passionate about it, and he's super knowledgeable about the product that he's designed and sells. It's helped a lot of grows. But yeah, it's
Dry
a
Flower, DRI, by the way, if you're trying to Google it, DRI.
Yeah, a great guy. And so, yeah, it's essentially a hang harvesting system. He has a couple different flavors, but it consists of different lengths sticks and then different widths of hangers. And the hangers have a square profile to the hang part, so it fits on a square bar. If you use a regular hanger, you get all that wobble. You have to balance plants. It becomes really difficult and challenging.
Yeah,
The
they
square
slide to one
profile,
side, right?
exactly. This square profile makes it foolproof, a lot easier to do with less care to how you put the plants on the hanger. But he has it down to capacities to where it's like, okay, I can fit this many plants, this much weight on this size hanger. He has different sizes for different scenarios, whether you're outdoor, indoor, getting through doors, etc. But what's nice is you load your plants onto your hangers, the hangers onto a stick, and then two people grab the front and back of that stick, and now you're moving a lot of plants at once. And if you can integrate that stick support into the PIP bulk rack, which what we've done, then you're essentially loading the plants onto the hangers and stick in the flower room on a mobile cart, wheeling it into the dry room, and then lifting that whole stick from the cart, which is kind of like your harvesting cart, straight to the racking system for the drying process. It's pretty sweet.
Yeah. Before we jump into climate, and now I'm realizing that I thought we could do drying and curing on this, and now I'm feeling like curing might have to be its own thing, but we'll roll with it and see what it looks like today. There's one more thing I'd like to talk about. It's not as common in the United States, but I saw a lot of it in Canada when I was working there pretty aggressively, and I do see it a lot internationally. And that is um, people are wet trimming before, like right at harvest, they're basically wet trimming, and then they're drying wet trimmed buds on,
Like
they can be,
shelves.
yeah, like perforated shelves, or like baking racks. And those, imagine like a baking rack at a bakery that's, full of cookies, except this one has weed, and instead of it being solid on the bottom, it's got a bunch of perforated holes. Um, Personally, it is not my favorite way to do things for a lot of different reasons, and I don't want to go too deep on that, but that is another option. Some of the challenges that I witnessed, specifically in Canada, with following GMP guidelines was it was really important what type of baker's rack that was on. What we were experiencing was is we were getting metal shavings
Ooh.
because it's metal in a lot of cases. It's rarely like an HDPE. Actually, I'll have to show you the archives of PIP. We had an HDPE drying shelf.
I've seen it.
Yeah, yeah.
Did you ever get the flat bud syndrome?
You totally get flat bud syndrome. It's the worst. Let's talk. Let's
There's, it's
talk
not
about
real
that.
syndrome. I just made that up being
No, that's
silly.
funny. That's
But,
solid. No, it's a great
you know,
comment. So, obviously, if you have a wet product and it's sitting, right, it's no different than I'm going to use the
so
cookie
for
example
clarification
again.
though, this is I would say the third process we talked about earlier where it's hook and hang versus whole plant. What you're describing is you're bucking the buds off the plant right at harvest. You are sending them through a wet trimmer, and then individual buds are being dried, on batch trays or like baker's type racks. And so this would be like kind of the third but less common route
Mhm.
coming from the flower room. Yeah, I'm glad you brought up an interesting one. I would say in the past, we only ever did that for stuff that was like falling off. We always had a little like
Your
mesh net
smalls.
hanger for smalls and stuff that would fall off or whatever.
Yep.
We
Yep.
would put them in there, but we experienced that too, where you put a wet bud on a flat surface to dry, it dries with a flat edge.
I mean, I'm going to use a cookie example again. It's like a cookie, right? So you have the top part of the cookie because it's nice and round and whatever has texture. The bottom's completely flat. So the same thing happens with the buds. So in theory, if you're doing it right, which I'm going to put in quotes, air quotes, because I feel like wet trimming is not doing it right. Um, you are going to have to like rotate. It's almost like a barbecue. You got to like rotate your chicken so it doesn't like burn on one side, you know? So you
Yeah.
have to actually rotate that stuff. So what are some of the pros? I'm going to go on a limb here because I don't want to just totally bash wet trimming and drying like that. But there's a lot less biomass in the room, and therefore things dry faster. Drying faster, though, I don't know if that's a pro.
Yep. I agree.
All right, now let's talk environment.
Okay. So I would say to start this conversation, let's first define what I would say is a pretty widely accepted industry standard, or at least what most people use as a jumping off point. And that's a 10 to 14 day drying period at 60 degrees Fahrenheit, 60% relative humidity. 60, 60, 10 to 14 days. I would say the Jungle Boys, give them credit. They largely popularized that, especially through social media. I mean, shout out to them in general for sharing so much information over the years. Mad respect to them for doing that. Um, I would say a lot of people did the 60, 60 to 10 to 14 days method, but I would say give them credit for popularizing it in industry wide.
Yeah, Ivan's always been really strong about putting like real helpful, actionable data in
Hell yeah.
posts, in comments. Like I don't even know how he had that much time when he was building that brand to be
It
that
was awesome.
active. It is
Yeah.
awesome.
Major credit for them. I
It's
even
for
used to read
people.
his posts on THC Farmer. I think
Yeah, I was
his
gonna
like
say,
Jack May Offer or something was his screen tag, like screen name there. And he did cocoa trials and all kinds of stuff. Like it was badass. I
yeah,
definitely
he
followed
brought a
him.
lot of that forum mentality into their social media, which if you're paying attention and halfway smart, you can learn a ton from the posts and the comments over the years.
Hmm. So anyways, back to it. That 60, 60, 10 to 14 days. So I guess to start, is that something you do?
It is. And I modulate a little bit at the end, but that is a great starting place.
Would you design your mechanical system for a new dry room off 60/60?
I was gonna say that's usually something I would usually kick to you in that situation, Anders. Yeah, I believe that would be accurate. Yeah, maybe even slightly more aggressive on the well, it's a good question. What is that? What is that temperature? There's like a temperature threshold. Once you go below a certain temperature, it just becomes like astronomically more
Refrigeration. It
expensive
becomes
from a refrigeration.
refrigeration. Yeah. Instead of conditioning, it becomes refrigeration. I think it's like 50. I don't quote me. I don't remember the cutoff.
Yeah.
Um,
I'd want to be just above that, whatever that number is. So you might actually go a little bit lower. Let's just say like I might go to 55 as like it's nice to have a little headspace on when I'm giving an HVAC provider something. So if I was targeting 60% RH, like at the end, I might throttle to 55% RH for the last couple of days to crisp it up. So like I know that I need to meet 55, which means I probably need to tell my design engineering team that I might need to hit 50 just to make sure that I've got that headspace. Now, sometimes people will give, you know this really well from your previous career, people will give HVAC and engineers like ridiculous numbers that are not, they're achievable, but they're not financially like responsibly achievable. They'll be
Sure.
like, "Oh,
It's a
I
great
want to
point.
freeze the room." And it's like, "No, you don't, because you don't want to pay the bill to allow you to freeze the room."
Yeah.
But tell me about your experience from Inspire and your HVAC days and kind of what you were coming across.
Sure. And I'm not an engineer. I don't come from the HVAC world. I purely got a job at a company called Inspire Transpiration Solutions, previously before PIP, kind of selfishly as a grower because I knew I needed to learn more about HVAC and dehumidification. It was just I didn't feel like I understood that system well, and it was a critical part of my operation. I couldn't find any great resources, so I said, the best way to learn it is just throw myself into that world. So
Art.
it was in particularly just understanding the loads of the rooms. I'm a biologist by trade, so studying the transpiration rates, the loads, the moisture content, water activity in dry rooms. That's how I brought a lot of value to the company. But I spent a lot of time on dry rooms and designed and sized a lot of systems for them. So it's interesting, the critical time of the drying process from a mechanical standpoint. And when I say mechanical, it's, cooling and dehumidification. I'll say right now that I would personally never build a dry room with dehumidifiers anymore. I just can't get an even dry. I would rather have an
Say that
integrated
again.
unit.
Within the room, you're saying a non-integrated, so like standalone.
No, 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 I would use an integrated system for my dry room. So utilizing like reheat is another term that people commonly refer to it as.
Hmm.
The reason being is efficiency and just even drying. It's really hard in these small dry rooms with dehumidifiers, creating little pockets of heat and moving air in all kinds of ways to get a very consistent dry through a room. Integrated units are much better for that, via ductwork. Um, so that would be my first.
Would you ever go with like an integrated unit and maybe have a supplemental dehumidifier that's maybe ducted in or rolls in potentially for the first day or two?
Yeah, and that's another valid strategy is you can save money up front on the size of your integrated unit and rely on, let's say, instead of let's just use round numbers to make it easy. Let's say your dry room without integrated dehumidification needed 10 dehumidifiers of whatever size. Instead, you sized your integrated unit to not have full capacity on day one, and instead you made that up with two standalone dehumidifiers or four or something like that, right? So it's a way to save a little bit of money on the actual integrated unit with reheat, and still have a little bit redundancy, I would say, with the standalone dehumidifiers. That's definitely a strategy that you can employ. Regardless, when it comes to sizing the system, whether you're talking integrated or non-integrated, you got to be able to size it for the day one load. And that's moisture removal rate, right? So typically that's people talk about pints per day in dehumidifiers. In most large facilities, the metric that's probably better to use is pounds per hour of moisture removal. Most cannabis is around 83% moisture content right at harvest. It's a really good idea to understand your total wet weight in, your total biomass weight into the flower room, and then you can use that data to size your system. In fact, there's three routes to really size the system that I ended up coming up with formulas for was total wet weight in. You can start with that if you have that information. You can do your canopy square footage of your flower room and your estimated grams per square foot, which then you can get to your wet weight in number with that info, or dry weight out. You can, if you know how much you're going to pull from a room, let's say it's an existing dry room, you can use that dry weight out data and work backwards to your wet weight in figures.
Hmm.
So
And
this is get
what are you multiplying when you work backwards from dry weight? Is that you're looking at that and like multiplying it by what, 83% or something to that nature?
yeah, you're adding the water content back in. So it depends on what the moisture content is of that dried product, and then you're bringing it back up to that 83% of
Hmm.
water weight removed. And so, but you need to come to the moisture removal rate number. The problem is what temperature and humidity do you want to remove that moisture at? So, right, I say this all the time, but I'm just going to say a Quest 506, for example, or an Andin 710, regardless of the manufacturer. Those units only remove, let's say, 506 or 710 pints per day at 80 degrees Fahrenheit and 60% relative humidity. The minute you get lower than 80, 60, And remember, we're talking about 60. That's 20 degrees colder. That unit is not going to do 506 pints per day or 710 pints per day. It's going to do far less than that. And so you got to understand that the moisture removal rate of mechanical equipment is dependent upon the temperature. It's easier to remove water at a warmer temperature. And so when you're sizing an integrated unit or dehumidifiers, you have to take into account the temperature at which you're going to dry. So for integrated units, I commonly would size at 65, 55, right? In fact, most HVAC manufacturers, their selection software don't even have data at 60 degrees and 60% relative humidity. It's
Mm-hmm.
such an insane condition from an HVAC manufacturer standpoint that they have to often run it through special software to even get you that moisture removal data of that unit. It's just not commonly requested in any other industry. 65 degrees, though, is actually weirdly easier to get.
Totally. Yeah. And that makes sense, right? You know, like
Yeah.
that's a reasonable number. But yeah, I've come across that same problem as well. And it's it's interesting. You know, when I think about drying and curing, it's like it's it's kind of this blend of like hippie folklore and like what someone learned from somebody and never questioned, you know, when there was that time period. But now we're utilizing certain tools and resources and water activity and moisture analysis meters and all these tools. And so it's kind of a blend of the two. And there's so many opinions on this topic. It's kind of like a hot topic to talk about because some people will adamantly swear by a
Yep.
certain approach, and anything outside of that is blasphemy. We've been just, you know, what we're talking about today is really kind of broad strokes around the industry from our personal experiences and what we experience with our customers, but it is all over the place.
All over the
Uh,
place. Like, for example, I was helping out a grower in their dry room where they were not removing moisture fast enough and having issues with mold. They were drying at 60, and the grower would not change that number. And I said, look, for the first 48 hours, just try it at 65 degrees because you're going to remove more moisture at 65 than 60. And it's actually significantly more moisture at
will you
65 than
explain that?
60.
Explain that because I think that's a really important thing that you said. I want to make sure that if someone's a newer listener, that they understand how raising the temperature results in greater moisture removal in most
So,
scenarios.
an easy way to think about it is just when you're looking at your set points for your dry room, a simple way of looking at it is just keep your relative humidity set point the same all the time, whether it's 55% or 60%. It's usually going to be somewhere between there. I usually keep mine at 55% on my relative humidity set point. And then I use my temperature set point as my gas pedal or my brake pedal for increasing the drying rate or slowing down the drying rate in my dry room. So let's say you start at 60 degrees right when your plants move in, and your relative humidity, your system can't keep it to set point. If your relative humidity keeps spiking in the first 48 hours, then bump your temperature up 1, 2 degrees at a time and see if that gives you the capacity to start dropping your relative humidity and increase the drying rate in your room. That's the easy way of doing it. You can also take moisture content and water activity samples out of the room to determine that as well. But this guy, he just would not allow himself to get through the mental block. He thought that at 65 degrees, his plants would off gas too many terpenes and his quality would suck. But he was worried about terpene loss when he was molding 20% of his crop. And that was the challenge I had with it. It was like some people are just very set in their ways when it comes to drying.
Let's talk about that for a second. So a lot of people are like, I don't speak for a lot of people. It's not uncommon for some people to learn that most of the microbial growth is actually in drying and less so in flower. And that they're in control of some of this stuff. You know, one of the big issues that I see is it always stems back to poor architectural design. But when we look at like common areas where things get bottlenecked or choked in a design, it's typically when we get to this side of things, it's typically the drying rooms. I can't tell you how many
Yeah.
people undersize their drying rooms. And so if you undersize your drying rooms, now you're like overstuffing the plant or you're just shoving so much biomass in there. I've had to deal with people who unfortunately undersize their drying room to the point where they were harvesting every week, but it forced them to basically have to dry in 7 days. And that is a rough situation. You, as a grower, you spend all this time and energy building and growing a beautiful plant, and preserving terpenes and doing all these things and creating this high tech. And then it goes to the drying room and it just turns into trash. You can take beautiful flower and just destroy it in a drying room if you don't know what you're doing. If the design is bad and the environmentals are bad, you can have all these microbial blooms. Um, and so it's, yeah, I mean, we haven't talked about airflow yet, but that's kind of the next thing we're going to roll into. But it's not uncommon for a drying room to be really inconsistent. When you go to like really take airflow samples or just environmental samples at different parts of it, it can be a small room and it can have like 6 or 7 different climates in there technically. So
Yeah.
really trying to balance out that space is so important.
I think I wanted to touch back something you just said around drying in 7 days or less than 10 to 14, right? So that's an interesting topic that I think a lot of more research needs to be done on, to be honest. You can design a dry room to take a crop from 83% moisture content down to 15% in 2 days if you want. There are systems out there that can remove that much moisture that fast, right? You don't want to do that, obviously, but it's possible. And there are a lot of facilities that we've both seen that, due to one reason or another, their drying room is undersized. They only have one of them. And to keep up with their harvest cycle, their facility, they physically can't keep that crop in the dry room longer than, say, 7 days because they have another one coming down right behind it. I've done some data collection on this. I'd love to see some more research done on this. I'm hoping that we can do it with PIP and the Cannabis Research Coalition and the dry room we built there in at Allison Justice's facility. But I don't know about you, but all the weed I've smoked that's dried for 7 days or less that quickly is super harsh to
Harsh.
smoke. And my hypothesis is that it has something to do with the enzymatic activity breaking down the chlorophyll molecule. And that chlorophyll takes more time to break down to produce a smoother smoke. I don't know if that's bullshit or not.
No,
Excuse
I
my
think
language, but
I think you're spot on. Let's just drill down there a little bit. So for people, chlorophyll is what gives the plants their green color, but it also has kind of a grassy, almost harsh taste when smoked. And so the drying curing process breaks down that chlorophyll and other organic materials that might otherwise affect flavor, leaving a smoother and cleaner product. But when we talk about curing and drying, it really can take anywhere from 2 to 4 weeks, with the longer cure time up to, some people will tell you it's not truly cured until it's 6 months later. I don't necessarily agree with that, but it's during that time that cannabinoids like THC continue to mature and develop, further improving the potency and just kind of general overall experience. Um, but it's challenging when you're forced to do something and you know that it's the wrong thing to do. I want to go back to design for a minute. If I believe that I have a spec design and I've done my calculations and it says for this facility I need 2 drying rooms or 4 drying rooms, I will spec 3 or 5 drying rooms. I'll build a flex drying room because things happen. Things happen in production. Things happen where you're like, it's not ready. And you're like, it has to come down. We don't have it, we don't have anywhere else to take this next crop. And that's where your flex drying space comes in. And I recognize that not everyone's going to have the ability to have this kind of creative freedom with their space. But if you are a little bit of a medium to large facility and you're building something bespoke, I would highly, strongly encourage you to build in these flex spaces in different parts of your post-harvest specifically. But one of those would be an extra drying room. Um, I can't tell you how many times that's saved the operation from a qualitative standpoint.
Mhm. Um,
Uh,
can
what
I
do you got?
quickly go through water activity? I think that's a
Yeah,
topic that is an interesting one
yeah. Will you
on drying.
define the differences between, I guess, water activity and moisture content? Because the two are not the same.
Yeah, and I hear them mixed up a lot.
Hmm.
Like I hear them call like moisture activity and kind of improper terms. So there's two different metrics that are pretty commonly used. And this is taken from actually the food safety industry primarily. This is where these devices and metrics are commonly used, is in like the drying of beef jerky, the drying of nuts, the drying of dried fruits, you name it, oatmeal bars, protein bars. Water activity and moisture content are commonly used by the FDA and food manufacturers to determine shelf life and product quality and safety. And we can use that same technology, these benchtop devices and meters, and the science that they've done over in the food safety industry and apply it to cannabis. So the first one is moisture content, and it's expressed in a percentage of essentially water to dry weight, desiccated material to water weight. Like I said, fully hydrated cannabis plants are almost always at 83% moisture content, weirdly enough. It's a pretty common number to get. And then most cannabis sold today, like in California, has to be 13% or less once it's dried. The other metric is water activity. And water activity in the food world is used to help determine shelf life and product safety. What it is it's a ratio or a metric from 0 to 1 water activity. And it's a measure of the freely available water in a product that organisms can use to grow. That's probably the
And one
simplest way to
one would
define
be
it.
pure water.
Pretty much, yeah. One would be the max. So a lot of freely available water for organisms to grow. At different water activities, as water activity decreases, there's not enough free water for certain organisms to grow. So, for example, one of the targets that myself and others like to target is after 48 to 72 hours into the drying process, get to zero point 0.8 water activity or below, but get to that zero point 0.8 threshold, because then you will be out of the danger zone of botrytis, which is probably one of the more promiscuous, or I don't even know what the heck that word is, the more common ones that you'll encounter in the dry room, right?
Sure.
And then slow down that moisture removal rate in your room and slowly bring that crop down to zero point 0.6 or 0.65. People debate the 0.65 and the zero point 0.6, but like in California, your product has to be below 0.65 water activity to be tested and sold. Most people believe that getting it to zero point 0.6 is really kind of the safest from a product quality standpoint. But as you go lower and lower, less and less organisms, molds, bacterias, etc., can actually grow. They halt all growth and end up dying off below certain water activities. So you can measure this. You would think there's a correlation between water activity and moisture content, and you're right. Unfortunately, it's not a common correlation. It depends upon the product. And what you and so this is called an isotherm for those that are curious and want to go do some of their own research. There are isotherm curves that exist out there for different products. Beef jerky has them, trail mix has them, and companies have started to produce isotherms for cannabis. The problem is a lot of it's strain specific. So different size buds and different genetics will dry at different rates and have different corresponding water activities and moisture contents. So you can't say, for example, that zero point 0.8 water activity is always X amount of moisture content. It doesn't work like that, unfortunately. It may be close, but it varies quite a bit. And so, but what's cool is there are benchtop devices you can purchase that measure both of these. Meter Group makes a very good one called the Aqualab that I've used quite a lot. It uses a chilled dew point mirror sensor that measures water activity directly and then uses an isotherm to calculate moisture content. And it's a really useful tool to have in your post-harvest area, from a shelf life, from a product quality, from a dialing in your drying room process. I use it all the time. I have one in a
Yeah.
Pelican case I bring with me
I'm
places.
trying to think. I've been using an A&D, I think it's MX50 or MX150, for that's for moisture analysis. That's not
Well,
for
so
watering.
what that device you just recommend, you just threw out there, I believe, if it's what I'm thinking of, is a loss on drying method moisture balance. And so what that does is it measures moisture content. It's literally a scale with an oven built into it.
Hmm.
And you put weed onto this little scale platform, close a chamber, and send that cannabis through a heating and drying cycle that's rapid at a high heat. It essentially removes all of the moisture from that product to 0% moisture content. And then it compares the weight from what you put it in to the weight
That's right.
completely desiccated and then gives you a moisture content value. It's a destructive analysis, whereas a chilled mirror dew point sensor is non-destructive. But
I
it's
think there's
still
some
a
infrared technologies out there too that a couple companies are offering. I was kind of going down that rabbit hole, but I haven't got any hands-on experience, but I'm trying to remember the name of that
yeah,
company.
I believe they use near infrared spectroscopy.
Sounds
And
right. Yep.
yep, it's called NIR. And it's even used in potency analysis. Near infrared spectroscopy is it needs to have a good reference value for it to be accurate, but it's gotten much better over the years. Regardless, I would say one thing to avoid is if you go to Home Depot and you see these moisture meters with prongs
Uh,
sticking out of them. I've
yeah, for
seen
wood.
people use those on bud. They're meant for lumber because
Yeah.
lumber also has to dry just like cannabis. Avoid using that thing with prongs. You know, it's used for lumber. It's just not an accurate reading at all.
It's the wrong tool. I see it. I actually see it. I don't say I see it often, but I see it from time to time. And it's like,
Yeah.
please don't use a $30 tool on a $300,000 crop.
We've also been trialing, there's a startup company out there called Grovera. We have no formal relationship with them, so this is just me shouting them out because I think it's a cool tool. They are a partner in our research program with the Cannabis Research Coalition, Dr. Allison Justice, and they make a clip sensor that
Mm,
clips onto the stalk or the bud and real time measures moisture content and water activity through the whole drying process. So instead of the like Aqualab where it's a single point measurement, you have to take multiple samples through the drying process. This device is recording it real time. I'm really excited to try them out. We have our first harvest coming down in a few weeks. We're going to start playing around with them and getting some data, but I'm excited to see how that
yeah,
works.
that's right. I remember you telling me about that. That's super cool. I know we're talking about some stuff that's slightly advanced or maybe even complicated to follow along. So I want to try and define a couple things around water activity and moisture content for someone who's just kind of easing into this topic. So I think of water activity um, as basically a way of measuring free water available for biological activity. It directly influences microbial growth. And that's the major difference between that and moisture content. So with moisture content, we're more so measuring like the total amount of water, which could be bound or unbound in the sample, but it doesn't necessarily correlate with microbial risks. And so while moisture content gives you like an idea of the dryness, water activity provides a more accurate assessment of potential microbial hazards or risks. And so that's kind of how I think of the two. I used to always talk in terms of moisture content and then kind of got leveled up into water activity years ago. And water activity is the main driver in the decision making for me in the drying process at this point when I'm
For
in
me, it's the
operations.
main driver, especially early. It's the one I care about most in the first 3 to 4 days to even week of the drying process is water activity. Moisture content is arguably more important to tell you when it's done, when your crop is done drying.
And that's kind of like, I don't know, I call that like it's like time to lock it in a little bit. Like, like, all right, I've reached the set point I'm looking for. Like now I want to lock this in and kind of start to allow the buds to equilibrate and retain terpenes.
Like you said earlier, there is a lot of art and science to the drying and curing process, and there's still a lot of unknowns. So it's almost like we're trying to use science to validate some of the art that people have
Yes.
learned through just trial and years of doing this. But it's impossible nowadays to expect one person in your facility to know that perfect snap of a branch, to know when something is done. And we all had that guy, we all had that skill, where you walk in a dry room and there's this one person in the facility who goes in and snaps a stem and goes, it's done. But no
I,
one
I,
else
st-
could reproduce that.
I still use the snap test. We didn't talk about the snap test. That's actually a worthwhile thing to define. If you do not have any tools available, maybe you're a home grower, the snap test has been probably de facto standard on like my product is getting close or is dry. And so typically you go to one of your stalks that your buds are hanging from and you're just trying to bend it, right? And if it bends and snaps and the outside of those buds are kind of crisp and the inside of it's got a little, a nice little bit of sticky moisture content to it, that was typically like, okay, it's ready or it's going to be ready tomorrow, kind of thing. But if it bends and doesn't snap, you know that you still have some, probably several days of drying ahead of you. But yeah, the snap test, we didn't talk about that. I'm glad you brought that up.
Yeah, it's an interesting one.
If you don't have a bunch of expensive tools to use like the snap test, I would say it's semi legit. You can get it done with the snap test.
Hmm.
All right, so I wanted to talk. We didn't really talk. We talked a little bit about labor efficiency to some degree between carts and racking, but we didn't really talk about like what does labor around managing your drying room look like, or maybe loading your drying room. So I'll just kind of give some examples from one of our facilities. We typically have weights and measurements that's happening in the drying room. We have someone that receives the plants. They're kind of an in-between person. So they're kind of receiving these carts and they're physically putting them on a hook system that's tied to a scale. So the hook is on the bottom of the scale. The scale is elevated, it has a nice digital readout. And then I typically have someone from compliance who is recording or managing the batch different when we switch from batch to batch and what each one of those plant weights are. Off record, most people are not weighing every single plant. They're basically saying, all right, I got 500 plants in this batch. I'm going to weigh 12 of them. I'm going to divide that number of wet weight by 12, get my average wet weight, and then I'm going to multiply that by 500. I would say probably 50, that might even be too generous. Probably 70% of all facilities are doing something like that. Now, certain states are required to do each one. Wet weight's a tricky one. It's like an important thing, but it would be impossible to validate that someone weighed each plant. There's just so many variable factors there. But so we'll typically in a drying room setup, I probably have three people working on the day of like receiving harvest. So someone bringing product in and kind of managing that to scale. And then I've got someone kind of working the scale. And then that same person that's bringing product in, they might also be feeding a person that is if they're on the first two tiers or on the floor, so they're able to kind of do it themselves, but they may have to get onto a ladder or a platform for a second or like a third or fourth tier. And so you may need someone on that side feeding that person. You typically want to keep that person, if they're on a ladder, let's just say, which is pretty common, you want to keep that person on the ladder. You don't want the person on the ladder to have to go up and down for every plant or every few plants. So you typically will have someone feeding the measurement weights and measurements kind of operation, and then you also have someone feeding post that, getting maybe up to where the person is hanging. And then so that's probably the most people that you'll ever have in the drying room. After that, I typically have one or two people that are dedicated to managing the drying process, and they are in there daily. Yeah, they're in there daily. They're at least having some inspections. But usually it's towards the later part of the cycle is where they're really getting active. They're measuring airflow. Sometimes, people are using just traditional fans that might be wall mounted or floor mounted or whatever. But the crop kind of changes, right? So you have that big poofy period where the crop is wet, it's fresh, it's holding onto a ton of water, and it's really like bloated. But within a few days, if you're drying appropriately, it shrivels to like what I don't even want to say it, a fifth, a sixth of the size. Everything kind of gets really small. But that being said, during that process, you may need to adjust the airflow between your kind of poofy period. I don't know why I'm saying poofy, but that's the word I've chose for today. And
Swollen, I don't know,
yeah,
moisture
yeah,
laden kind of period. Yep.
yeah. You sound more scientific, so that's good. But but yeah, you may need to adjust your fan locations, the velocity of your fans, or however you're moving airflow through the space. It's not uncommon to have someone just over drying a product that's right by a fan. I'm typically not trying to position a fan so it's like on the crop itself. I'm trying to like hit a wall and maybe let it drift down a wall, or I might be trying to shoot up or like in between the tiers potentially as well.
I think that's why you hear a lot of people debating pushing or pulling air through a dry room.
Yes. Yeah. And
A
we've seen
lot of
that
people
with
don't
like,
like to blow air directly in a dry room. Instead, they face fans upwards and they draw air through a drying room.
mhm.
Um, yeah, that's a common conversation in those
Yeah.
designs.
One of the cleanest dry rooms I saw was provided by Conviron Chambers. It's a really expensive solution. I want to say it was north of $300 a square foot. So it's not, not for everybody, but the concept of it was really nice. I know we've talked about this before, but the concept is essentially there's two of your walls on your drying rooms on each side, not the short wall, but maybe the longer wall. Those are all perforated holes, and there's a lung or chamber on each side of that wall, and it's basically just pulling air like perfectly through the crop. Since we talked about this, I didn't highlight this, but I'm going to highlight it as another pro to try and get you to change your mind on carts versus racks. So one of the things I love about the racks, which you do not achieve with the carts, is I typically have anywhere from 12 to 18 inches between the each elevation that has no flower on it. So like the top of the buds will be that are hanging have about a foot or so gap before the next set of stalks are
Hmm.
there, and it allows me to have like an airflow flue or chamber for me to move air. And if you think about where the top of the colas are, that's usually the thickest, chunkiest, has the most moisture. And so it allows me to kind of the racking system gives me these like 12 to 18-inch buffers, depending on how big of a crop you're growing on each tier. Whereas if I have the drying carts, because the carts aren't super tall, it's just like a wall of flour. You know what I'm saying?
It's a fair point.
Did it sway you at all? Well, holding steady. All right. I'll work on
Well,
that.
maybe.
Okay.
I don't know.
Um, let's see. How do we bring this talk home? I know we were going to talk about curing, but now I kind of feel like unless curing is the ender and we keep it small, but I feel like that might have to be another episode.
It may be another episode. I think the highlight here is that there's a few fundamentals that are not up for debate in drying. I think there are some best practices and there are some engineering and science that works. Like for example, it's always easier to move moisture at warmer temperatures, right? And then there are sort of the intangibles and some of the qualitative opinions in drying, whole plant versus hook and hang or whatever. I would say take everything we're saying with a grain of salt. Of course, do your own homework, have your own opinions. But there's a lot of different ways to do this. As long as you're putting out a good product at the end of the day, that's all that matters. A safe, high quality product. I think that's
And
the
if you're
goal.
not happy with your solution, we mentioned that these standalone dehumidifiers, if they're not ducted appropriately or if they're in the room and not on top of the lid, they can create more microclimates and these like little heat zones. And so if you're saying, gosh, my crop isn't drying really consistently, you have to look around that space and say, well, what's creating this? And also mapping out all that in your room, even if it's a small drying room, go ahead and take the time. What is the temperature and RH at this elevation, at this part of the room, at this next elevation, at this part of the room, and then starting to play around with airflow. With airflow, too much is too much. It'll just dry out your product and you're going to lose your terpenes. But finding that balance, and there aren't a lot of good data points or white papers on this. And as Anders alluded to earlier, working with the Cannabis Research Coalition and Allison Justice and her team there in South Carolina, we're hoping to address this stuff in the future. And as you guys know from if you've listened to any of our podcasts, we are trying to share as much of our knowledge, experiences, and the facts as we believe them to be as possible. And so when all that data becomes available, be sure that we're going to be sharing it. But yeah, I would say, you know, big takeaways for me, the quality of cannabis drying and curing significantly impacts the final product. And so it's such an overlooked part. And so when people are trying to improve their brand identity, if your flower's grown pretty decent to good to almost great in flower, you're most likely your challenges and what's degrading your product is most likely starts in the drying room. And then it probably can be a little bit worse after that too. But the drying part is a part that a lot of people do not nail.
I agree. And if I could give some people one piece of advice on running a drying room, it would be keep the lights off, keep the door shut.
Stay out of there.
Stay out of it.
You know? Yeah,
So
don't go
many
in there and
times I see that
fondle
door open,
plants.
lights are on, doors are open. Put the lights like when I design dry rooms, I put the lights on a timer
Hmm.
so that they're never left on by accident, and I put the doors on automatic closers so that they're always shut.
Love it. And make sure you have, as Anders highlighted, make sure that, a lot of people think about like light proofing their like flower rooms is a big priority for a lot of people, but your drying room, you should do all the smoke seal and all the thresholds and make sure you have the bottom sweep and really seal those doors up. Try and lock all that in there and keep it as consistent as possible.
Mhm.
All
Cool.
right. Is that a wrap?
That's a wrap. I think we'll pick up on curing next time.
Okay. Well, as always, guys, thank you for listening. And we are interested in talking about what you're interested in listening to. So feel free to drop a comment on whatever platform you're listening to. You can send us an email. All those things were really easy to find and get a hold of. So if you've got a topic you want to hear about, we want to know about it because we want to talk about it. And that's it.
See you guys. Thanks for listening.
Later. Thank you.